In the rapidly evolving world of software engineering, the rise of large language models has sparked a revolution, not just in how we write code, but in how we think about software development itself. For decades, researchers and practitioners have sought ways to automate repetitive, time-consuming tasks. But until now, no technology offered the scale, flexibility, and contextual understanding that modern LLMs bring to the table. Today, we're diving deep into a real-world application of agentic AI, where autonomous AI agents don't just assist, but collaborate to solve two of the most persistent challenges in software engineering: test scenario generation from natural language requirements, and intelligent document retrieval across complex software development lifecycles. Let's start with the problem. In most software projects, the foundation of development is a functional specification document, often dozens of pages long, filled with detailed descriptions of features, behaviors, and user interactions. These documents are essential. They guide design, inform implementation, and serve as the basis for testing. But here's the catch: creating test scenarios manually from them is slow, error-prone, and expensive. Traditionally, QA engineers spend days translating vague or semi-formal natural language into structured, executable test cases. This process is not only labor-intensive, it's also ripe for oversight. Missed edge cases, ambiguous phrasing, or misinterpretations can slip through, leading to bugs that could have been caught earlier. Our solution: a multi-agent AI system built around a star topology, one supervisor agent orchestrating 5 specialized worker agents, each with a clear role. Here's how it works. The process begins when a user requests a test scenario for a specific section, say, password management. The system first pre-processes the full document, extracting text and analyzing any embedded images using a vision language model. Then, the retriever agent identifies and extracts the relevant chapter. It sends that content back to the supervisor. Next, the test scenario writer agent takes the extracted text and generates a structured test scenario in Markdown, following a predefined format that ensures consistency. But here's the critical safeguard: the fact-checker agent doesn't just passively accept the output. It cross-references the generated test case against the original specification, checking for accuracy, completeness, and logical consistency. If discrepancies are found, say, a test assumes a feature exists that wasn't mentioned, the system triggers a feedback loop. The supervisor re-engages the writer with corrective guidance. This loop continues until the test scenario is factually sound. Once validated, the translator agent converts the scenario into the required language, crucial in multinational teams where the client demands documentation in a specific language. Finally, the Excel writer agent converts the structured Markdown into a properly formatted Excel file, complete with columns for test ID, preconditions, steps, expected results, and status. All of this happens automatically, end-to-end, in under a minute. And the result: a high-fidelity, traceable, and verifiable test scenario, ready for manual or automated execution. Now let's pivot to the second challenge: document management. Throughout a software project's lifecycle, hundreds of documents accumulate: requirement specs, design proposals, meeting minutes, commit logs, change requests. Over time, these evolve. Versions proliferate. Context is lost. New team members struggle to understand why a decision was made. Senior engineers spend hours searching for a single sentence buried in a 50-page document. To solve this, we built a unified agentic AI system that acts as a cognitive layer over all project documentation. At its core is a delegator agent, an intelligent router that listens to the user's request and decides which specialized agent should respond. There are 4 primary use cases. First, general search. When you ask, "Find all documents discussing authentication flows," the system doesn't just return a list of files. It performs semantic retrieval, filters out irrelevant results, summarizes each document, and presents them in 2 tiers. The most relevant documents first, followed by supplementary materials, organized by relevance. Second, question answering. Ask, "What was the policy on password reset timeouts in version 2.3? The system retrieves all relevant documents, analyzes each one, and generates a precise answer, backed by direct quotes from the source. If no document contains the answer, it tells you clearly, "I cannot answer this based on available documents." Third, change tracking or trace. This is where things get powerful. Want to know how a requirement evolved? Ask, "How did the session expiration rule change between versions 1 and 3.1? The system traces the requirement across every version of every document, reconstructs its history, and presents a timeline, showing exactly when and where changes occurred. Fourth, document reading, for those ultra-long documents that exceed an LLM's context window. Instead of failing, the system uses a divide-and-conquer strategy. It splits the document into blocks, reads each one in isolation, maintains a running summary in memory, clears its context after each block, and updates its overall understanding. Only after processing the entire document does it generate a final response to your query, like, "Which chapter contains the section on multi-factor authentication?" All 4 use cases are powered by dedicated LLM-based agents, all sharing a centralized QDRANT vector database of documents. The delegator ensures the right tool is used for the right job. No more one-size-fits-all AI. But why go through all this complexity? Why not just use a single LLM with a prompt? Because agentic AI isn't just about automation. It's about structured reasoning, verification, and robustness. By breaking tasks into specialized, accountable components, we reduce hallucinations, improve traceability, and allow for human-in-the-loop validation. And crucially, these systems aren't just theoretical. They're deployed daily in a real-world software engineering firm. We're collecting usage data, refining prompts, improving agent coordination, and learning from the edge cases that arise in production. Looking ahead, our vision is clear. Extend this framework to other SDLC tasks, like automated code review, requirement traceability, API contract generation, and even technical debt identification. We're not replacing developers. We're empowering them, freeing them from repetitive work so they can focus on what they do best, solving hard problems, designing elegant systems, and innovating. This is the future of software engineering, not AI writing code for us, but AI collaborating with us, acting as intelligent co-pilots across every phase of development. And as LLMs grow more capable and agent architectures more sophisticated, the possibilities are only beginning to unfold. If you're building software, managing documentation, or just curious about how AI is reshaping engineering, this is a moment to pay attention. Because the tools aren't coming. They're already here.